Subscribe to LearnCab and hit the bell icon to get notified.
Welcome back to the keywords. The next keyword I am going to discuss is mathematical property. From the keyword mathematical property, questions is appearing in your exam. Only 4 measures is having mathematical property. They are arithmetic mean, geometric mean, harmonic mean, then the standard deviation. These are the only 4 measures which is having mathematical property. Mathematical property means the average weight of 60 students is 72. Later, the teacher found that one of the students' weight is 80, which is incorrectly taken as 125 kg. Then, will you able to correct it and find out the new corrected average? So, such kind of scenario is called mathematical property. Once one of the values getting wrong, then can you correct it back? That is the intention behind of mathematical property. So, only 4 measures: arithmetic mean, geometric mean, harmonic mean and standard deviation is having mathematical property. So, let's go for the question based on mathematical property. Question number 15. Which of the measure is not having mathematical property? So, option A arithmetic mean, option B geometric mean, option C median, option D standard deviation. So, not having mathematical property. Arithmetic mean is having mathematical property, geometric mean is also having mathematical property, standard deviation is also having mathematical property. So, the measure which is not having mathematical property is median. So, median is the right answer. So, answer is median. Here there is one confusing factor is there. Suppose a student don't know this rule, he is thinking that arithmetic mean is a measure of central tendency, geometric mean is also a measure of central tendency, median is again another measure of central tendency, but standard deviation is not a measure of central tendency. So, he may go for standard deviation, but that is incorrect. So, the correct answer is the measure which is not having mathematical property is median. AM is having mathematical property, GM is having mathematical property, standard deviation is having mathematical property. Welcome to the keyword relationship. From the relationship, there are many relations with different measures. Arithmetic mean, median, mode is having some kind of relations. They have some formula. Geometric mean, harmonic mean and arithmetic mean is having another kind of relationship. Mean, variance of normal distribution, then mean deviation, quartile deviation, mean and variance of binomial distribution, they having some kind of relationship. In the previous exam, 2019 May foundation exam, they tested a good number of questions from the term relationship. Let's examine one after another. In normal distribution, mean deviation is equal to 0.8 times standard deviation. That means 80% of standard deviation is mean deviation. So, this means standard deviation is 100%, mean deviation is only 80% of standard deviation. So, reverse is possible. Standard deviation is 1.25 times of mean deviation. 1 by 0.8 which is equal to 1.25 times. So, standard deviation is 125% of mean deviation, which is 25% higher than the mean deviation. Quartile deviation is 0.675 times standard deviation, that is quartile deviation is 67.5 times of standard deviation. So, bigger one is standard deviation which is 100%. Next bigger one is mean deviation which is 80% of standard deviation. The third one is quartile deviation, which is 67.5% of standard deviation. The reverse is possible. Standard deviation is 1.5 times of quartile deviation, 1.5 times of quartile deviation. So the bigger measure is standard deviation. So standard deviation is greater than mean deviation, which is greater than quartile deviation. Okay, now let's see another kind of relationship. The same term, 0.8 means it is 4 by 5. 0.8 means it is 4 by 5. So mean deviation is equal to 4 by 5 times standard deviation, and standard deviation is 1.25 times. 1.25 times means it is 5 by 4 times mean deviation. Then the quartile deviation is, which is 0.675 times standard deviation, which is approximately equal to 2 by 3, which is exactly incorrect, but in the multiple choice QD equal to 2 by 3 standard deviation is a regularly asking question. Actually 2 by 3 means 66.66%, but the formula says QD is 67.5%. 67.5%. There is a difference of around 1%, but even though we used to say QD equal to 2 by 3 SD, and the reverse is possible, SD is equal to 3 by 2 QD. And let's see the biggest measure. I told you standard deviation is the biggest one, mean deviation is next one, quartile deviation is smallest one. So smallest one is quartile deviation. So quartile deviation less than mean deviation less than standard deviation, and standard deviation greater than mean deviation greater than quartile deviation. Now from the relationship, what I am going to explain some questions which appeared in the previous year. I am going to explain some questions which appeared in the previous year. From this table, two questions is appeared in 2015 December. In one examination, two questions appeared from this single slide, that is standard deviation is equal to 3 by 2 times of quartile deviation. Then second question, standard deviation greater than mean deviation greater than quartile deviation. So these two questions appeared in 2015 December. Next is relationship among arithmetic mean, geometric mean and harmonic mean. First one, for a set of positive observation AM greater than or equal to GM greater than or equal to HM. This is the only formula which is inside the textbook, but in your exam this formula is not tested. They tested only the second one. For a set of distinct positive observation AM greater than GM greater than HM, always the biggest number is arithmetic mean, the next biggest is GM, the least one is HM. For a distinct number, distinct means different numbers, and if all the observations are same, AM, GM, HM will be same. Now let me prove this. There are two numbers, one is 9 and 4. The arithmetic mean of 9 and 4 is 9 plus 4 divided by 2, that is 13 divided by 2, it is 6.5. The geometric mean of these two numbers is root of 9 into 4, that is root 36. Root 36 is nothing but 6, and the harmonic mean of these numbers, it is 2ab divided by a plus b, that is 2 into 9 into 4 divided by 9 plus 4, which is equal to 5.5. So the biggest number is arithmetic mean, next biggest is geometric mean, the least one is harmonic mean. For a set of distinct positive observation AM greater than GM greater than HM, this question was tested in the recent past 3 times. After 2014, this question appeared 3 times in your exam. 3 times. This question after 2014, This question appeared after 2014. This question appeared 3 times in your exam. So please remember, this question, this relationship is not there inside your textbook, but which is there on your set A of the multiple choice of the textbook. So this question is tested in 3 times in the last, after 2014, this question tested 3 times. Then the other relationship is arithmetic mean into harmonic mean is equal to GM square, geometric square of geometric mean. Arithmetic mean into harmonic mean is equal to geometric mean square. So AM equal to, arithmetic mean equal to GM square by HM, square of geometric mean divided by harmonic mean. Similarly, HM equal to GM square by AM and GM equal to root of AH. This could be tested for this equation. This relationship could be used for testing the multiple choices, especially for problems. Let's see the question. This question appeared more than 3 times in your exam. Arithmetic mean and harmonic mean are 5 and 3.2. Find the geometric mean. So AM is 5, GM is not given, you have to find out GM, but HM is 3.2, but GM equal to root AH, root of arithmetic mean into harmonic mean, that is 5 into 3.2. Find out the root of 5 into 3.2. 5 into 3.2 is 16, root of 16 equal to 4. So this question is there on your set B of measure of central tendency, but this question appeared more than 3 times in your exam. So the answer of this question is 4. Now another relationship question which came from AM, GM and HM in 2017 June, they tested question. Arithmetic mean and geometric mean are 6.5 and 6 respectively. Find harmonic mean. I proved harmonic mean equal to GM square divided by arithmetic mean. Harmonic mean is equal to GM square divided by arithmetic mean. What is GM here? GM in this question is 6 and arithmetic mean is 6.5. So the answer could be 6 square divided by 6.5. In the multiple choice, they never solved this question, but instead they asked the values. So 6 square divided by 6.5. So the answer is there, 6 square divided by 6.5. Next, relationship among AM, median, mode. Arithmetic mean, median, mode. The first one, in a grouped frequency data, always the biggest value arithmetic mean. That is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. In that kind of class, the bigger value will be arithmetic mean. So AM greater than, median greater than, mode. Then the very important formula is mean minus mode equal to 3 into mean minus median. This formula could be tested as a problem question in 2 different ways, which I will be covered in the chapter measure of central tendency and measure of dispersion, and the formula itself is tested in 2015 December, 2017 itself, and one more times in CF foundation. So that much important this formula is having. In 2018 November foundation also this formula was tested. So the formula is very important. Mean minus mode is equal to 3 into mean minus median. So for problems there is one more formula. Suppose they are asking arithmetic mean is so and so, suppose arithmetic mean is 60, median is 52, find mode. Then you can use a simplified formula of these. Mode is equal to 3 median minus 2 mean, or they are asking median is equal to 60, mode is equal to 50, find mean. Again also you can use this formula, mode is equal to 3 median minus 2 mean, which will be covered in measure of central tendency, problems of that. Okay, next, relationship in index number. So last Pierce, Pascal's and Fisher's index number, they have some connection. Let's see, Fisher's index number is equal to root of L into P, that is geometric mean, simple geometric mean of last Pierce and Pascal's. In some exam they are testing Fisher's index number is dash of last Pierce and Pascal's. It's the simple geometric mean of two number is square root of their number, square root of their product, that is root LP, and F square, that is Fisher square, equal to L into P, and L is equal to F square by P, and P is equal to F square by L. In your exam they may ask some questions like this, okay, they may ask some questions like this. Fisher's index number is 136, last Pierce index number is 130, find Pascal's. So Pascal's is equal to Fisher's square divided by last Pierce. So they can ask questions like that. Let's see one question. Fisher's index number is 138, Pascal's index number is 124, find last Pierce index number. This is the question, okay. Last Pierce index number means this is L, L is equal to F square by P. So what is the value of F? Fisher's index number is 138. So 138 into 138, that is 138 square divided by 124. So the answer is 153.58. So answer is 153.58 is the answer. This in 2012 December, a question of similar nature, I have just changed the values, is appeared in 2012 December. So it's very, very important. Now you got the value of last Pierce, you got the value of Pascal's, which is already there in the question. It is 124. They can ask the question in another way. Fisher's index number is 138, Pascal's index number is 124, find Bowley. Bowley's index number remains is the simple arithmetic mean of last Pierce and Pascal's. Already you know that Pascal's index number is 124 and last Pierce index number is 153.58, which you already got. Now they are asking find Bowley. Then what do you have to do? Last Pierce plus Pascal's divided by 2, that is 153.58 plus 124 divided by 2. So Bowley's index number is 138.79. Please note that, please remember that Bowley's index number will be slightly higher than the Fisher's. If Fisher's is 138, Bowley will be little bit higher than the Fisher's, because Bowley is arithmetic mean, Fisher is geometric mean. So arithmetic mean will be always a little bit higher than geometric mean. So sometimes you don't need any time. With this simple logic also you can crack some questions. Now the relationship between Bowley, we discussed Bowley is equal to last Pierce plus Pascal's divided by 2, that is simple arithmetic mean of last Pierce and Pascal's is the Bowley. So 2 into Bowley equal to L plus P, then L is equal to 2B minus P, P is equal to 2B minus L. So this could be, there are some questions from this area also could be tested in your exam. Let's see one question, okay. Bowley's index number is 132, Pascal's index number is 120, find last Pierce. Here the formula which we wrote for finding last Pierce is 2B minus P, that is 2 into Bowley minus Pascal's. The value of Bowley is 132, so 2 into 132 minus the value of Pascal's is 120, so the answer is 144 is the answer. So you can crack the question is 144. Now you got the value of Pascal's is 144. Suppose they are asking what is the value of Fisher's. Pascal's is 144. So what if 144 into Fisher's means simple geometric mean of last Pierce and Pascal's. Last Pierce index number is 144. Pascal's index number is 120. So Fisher is 144 into 120, okay, and the square root of the answer, that is 131.45, which is little bit less than the Bowley which is 132. The next keyword, welcome back. The next keyword is linear and non-linear. From the word linear relationship and non-linear relationship, there are some questions is coming. For finding the correlation, there are 4 types of correlation. One is scatter diagram, second one is Spearman's rank correlation, third one is Carl Pearson's correlation, and finally the concurrent deviation is there. For finding the correlation in scatter diagram, if it is a linear and if it is a non-linear, you will be able, it will be possible. In scatter diagram, one can find out the correlation if there is linear relationship and if there is no linear relationship. So if it is a linear, you can find out the answer. If it is a non-linear, then also you can find out the answer. So yes, linear is yes, non-linear is also yes. In Spearman rank correlation also, if it is linear you can find out, if it is non-linear also you can find out. But in Carl Pearson, you cannot find out correlation if it's a non-linear. The relationship to find out the correlation should be linear. It should be a mathematical relationship like y is equal to a plus bx, like that. It should not be y is equal to a to the power b raised to x raised to exponential. Okay, this relationship should be linear in Carl Pearson's. So you can remember this point. Scatter is starting with the letter S. Spearman is also starting with the letter S. Both correlations starting with S are S to both. That means S to linear, S to non-linear. So you can remember like that. The question which is coming in your exam is like this. In scatter diagram, the association need not be linear. Option A true, option B false, option C partly true, option D partly false. So in scatter diagram, one can find out correlation if there is linear relationship, and if there is not linear relationship, that is true. Next, I am giving you some questions from the chapter called index number. From the chapter called index number, there are some tests of adequacy. The first question is asking in your exam, how many tests of adequacy are there? There are unit test, time reversal test, factor reversal test, circular test. There are 4 tests of adequacy are there. This is the first question which they are going to ask from the word tests of adequacy. Now you should know which are the measures like last year's index number, past index number, Fisher's index number. Very specially last year's, past and Fisher's. Which are the tests they are satisfying, which are the tests they are not satisfying. Also the test is, among the 4 tests, 3 tests is having formula, of which the formula of circular test is not given in your textbook, but it was tested once in your exam. So you should also learn the formula of circular test. So questions from these is very common in your exam. Maybe from this table itself you can expect 2 questions in your exam. From this single table I am going to give you many questions. Let's see. Unit test. There is a formula, there is a definition for unit test. It's related to unit. The unit should be independent of both quantity and prices. That is the definition of unit test. So who are satisfying the unit test? Last year's method is satisfying, past's method is satisfying, Fisher's method is satisfying. So all the 3, last year's, past's, Fisher's, we are not considering, we are not bothering about Marshall, Arjwat, Kelly and Bowley something. Basically questions will be concentrated on these 3. So last year's is satisfying, past's is satisfying, Fisher is satisfying. Who is not satisfying? This is a very important question. Simple unweighted aggregative index is not satisfying the unit test. It's very important. Now next is time reversal test. There is 2 definitions for time reversal test in your exam. There is little possibility, there is a less chance, there is a slight chance to ask the definitions of time reversal test. There are 2 definitions which you can learn from your textbook, and there is a very important formula. For me, the most important is formula P01 into P10 equal to 1. The base on the current on the base should multiply into unity. Instead of P01 into P10 equal to 1, they tell base on the current on the base should multiply into unity is dash test, is time reversal test. And who are satisfying time reversal test? It is Fisher's index number is satisfying. Actually, that is enough for our exam is considered, but Marshall-Edgeworth is also satisfying. Kelly's index number is also satisfying. In your CA foundation exam is concerned, even Fisher's is satisfying. That is enough. And last Pierce and Pasque's method, they are not satisfying the time reversal test. This is very important. Okay, now the factor reversal test is this is a test which holds when the price index and the quantity index should be equal to corresponding value index. Value index means V01. V01 means sigma P1 Q1 divided by P0 Q0, that is cost of living index. Okay, suppose in your exam they are asking find factor reversal. They are given some data, they are given some quantity, they are given some prices, and they are asking find factor reversal test. Then you have to find out sigma P1 Q1 divided by sigma P0 Q0. So the formula for factor reversal test is P01 into Q01 equal to V01. This test is also satisfied by Fisher's index number. This test is not satisfied by Laspier's and Pasque's method. Now, of the first three tests, Fisher is satisfying all the three, but Laspier's and Pasque's is satisfying only the first one. Second test, time reversal test. Third test, factor reversal test, is not satisfied by Laspier's, Pasque's and Fisher's. Fisher is satisfying the first three. So Fisher is satisfying unit test, time reversal test, factor reversal test. The measure of index number, the one of the measure of index number which is satisfying both time reversal test and factor reversal test is Fisher's index number. So Fisher's index number is called ideal. Fisher's index number is called ideal. In 2019 June foundation exam, which measure of central tendency is called ideal? Answer is Fisher's. Fisher's index number is called ideal because it satisfies time reversal test as well as factor reversal test. So that is very, very important. That question is tested in the last exam. Now circular test. Circular test, there is a formula which is not there on your textbook, but this formula was tested in a reverse order. Instead of P01 into P10 into P20 equal to 1, they asked in the exam what is the formula for circular test. Option A, P01 into P10 into P20 equal to 1. Option B, P01 into P12 into P21 equal to 1, something like that. So you should by heart it very specifically. P01 into P10 into P20 equal to 1 is called circular test. The test of shifting the base is also known as circular, and this test is satisfied by, it is not satisfied by Laspier's, it is not satisfied by Pasque's, this is not satisfied by Fisher's. That is the most important. Laspier's is not satisfied, Pasque's is not satisfied, Fisher's is not satisfied. Fisher is satisfying the first three, but the last test, circular, is not at all satisfied by Fisher. And this test is satisfied by simple unweighted aggregative index and weighted aggregative with fixed weight. Is very, very important. Who is satisfying circular test? Answer, simple unweighted aggregative index and weighted aggregative with fixed weights. That is very, very important. From this table they can ask you, they can ask many questions. Factor reversal test is satisfied by option A Fisher, option B Laspier's, option C Pasque's, like that. Option D, none of these. Factor reversal test is satisfied by Laspier's, Pasque's and Fisher's. The only measure is satisfying factor reversal test is Fisher's index number. Next, the chapter, I am giving you some hints from the new chapter called time series. From the chapter time series, there are many questions. How many measures are there? How many? There is one funny thing. For all the questions other than one question, the answer is 4. How many? The answer is 4. The question which is having answer other than 4 is how many models of time series are there? There are only 2 models. One is additive model, second one multiplicative model. First one is additive model, second one is additive model. Other than all other question, is having answer for. How many components a time series having? 4 components. Long-term components, seasonal variation, cyclical variation, irregular variation. How many methods are measuring for long-term trend? Answer is 4. The answer of that is GM cube. GM cube means graphical method, method of semi-average, method of moving average, method of least square, among which the most important method is method of semi-average. That is the one question which is tested in 2019 exam of foundation.
Subscribe to LearnCab and hit the bell icon to get notified.